Trigonometry. Let's see. This clip.
Right triangles. So if you're trying to find the trig functions of angles that aren't part of right triangles, we're going to see that we're going to have to construct right triangles. But let's just focus on the right triangles for now. So let's say that I have a triangle where, let's say this length down here is 7, and let's say the length of this side up here, let's say that that is 4, and let's figure out what the hypotenuse over here is going to be.
Let's see. The opposite of 90 degree is, we can use Pythagoras. Try ลองหาสิคะ
We know it's called the hypotenuse h. We know that h squared is going to be equal to 7 squared.
What's the answer? What's your answer?
Plus 4 squared. We know that from the Pythagorean theorem, that the hypotenuse squared is equal to the square of each of the sum of the squares of the other two sides. H squared is equal to 7 squared plus 4 squared. So this is equal to 49 plus 16. 49 plus 16. See, 49 plus 10 is 59. Plus 6 is 65. It is 65. So this h squared, we write h squared, it's a different shade of yellow. So we have h squared is equal to 65. Did I get that right? 49 plus 10 is 59, plus another 6 is 65. Or we could say that h is...
H is... Hands up. Okay.
It's equal to, if we take the square root of both sides, square root of 65. We really can't simplify this at all. This is 13. This is the same thing as 13 times 5. Both of those are not perfect squares, and they're both prime, so you can't simplify this anymore. So this is equal to the square root of 65. Now let's find the trig. Let's find the trig functions for this angle up here. Let's call that angle up there theta. So whenever you do it, you always want to write down, at least for me it works out to write down. Let's do, just for simplicity, let's say that this side is 3, this side is 4, and the hypotenuse is 5. So the trig functions tell you that for any angle, it tells you what the ratios of the sides of the triangle are relative to that angle. Let me give you an example. Let's call this angle theta. Theta is the Greek alphabet people tend to use for the angle that you're going to find the trig.
Theta is between 5 and 4.
Function of. Let's say you wanted to find the sine, and SIN is short for SINE. Let's say you wanted to find the sine of theta.
Sine of theta equals to 4 over 5. 4 over 5.
So before we solve the sine of theta, I'm just going to throw out a mnemonic that I remembered when I was in school, and I carried it every time. Every time I have a trig problem, I actually write it down on the paper, or at least repeat it to myself. This is SOHCAHTOA. I have vague memories of my math teacher in high school, so I'm just worried about some Indian princess who's but I forget. But all you have to remember is SOHCAHTOA. Now you might say, well, what is SOHCAHTOA? Well, SOHCAHTOA says that sine
is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And that's going to be confusing right now, but we're going to do a lot of examples, and I think it's going to make sense. So let's go back to this problem. We want to know what the sine of theta. Theta is this angle in the triangle. So let's go to our mnemonic, so katoa. So which one is sine? Well, S for sine. So we use so. And we know that sine from this mnemonic, sine of, let's say, theta is equal to opposite over hypotenuse. Opposite over hypotenuse. Okay, so let's just figure out the opposite and the hypotenuse are. Well, what is the opposite side of this angle? Excuse me. Well, if we just go opposite the angle, let's go here. The opposite side is 4. Is this length of 4? So this side is the opposite. Now, which side is the hypotenuse? We know this one. We know this in the Pythagorean theorem modules. The long side, or the side opposite the right angle, is the hypotenuse. So that is the hypotenuse. So now I think we're ready to figure out what the sine of theta is. The sine, sine of theta is equal to the opposite side, 4, over the hypotenuse, which is 5. We're done. Let's figure out what, let me erase part of this, and we'll figure out some more things about this triangle. I think if you practice this, you'll realize this is probably one of the easier things to do in mathematics. It's actually shocking that they wait until pre-calculus to teach this because of the smart middle schooler who teach them. Not to make you feel bad if you're not getting it, just to give you confidence that you will get it and you realize that it's very simple. Let's go back to, okay, so let's figure out what the cosine. COS is short for cosine. I'll write it down. Cosine. I'm sure you see it. So what is the cosine of theta?
Cosine, short form is cos, short form. Okay? Cos of theta. Next. What's the answer? 3 over 5.
It's opposite the angle. This side's the hypotenuse, that's the longest side. And then you can just by deductive reasoning, but also just by looking at it, you see that this side right here, the side of length 3, is adjacent to the angle, right? Adjacent means right beside it. And that's the adjacent side. We already figured out that the hypotenuse is the side that I put in pink. So we're ready to figure out what cosine of theta equals. Cosine of theta is equal to the adjacent side, that's 3, over the hypotenuse, which is this big side.
3 over 5.
Pretty straightforward, isn't it? Let's do another one.
And the last one.
The tangent is the opposite over the adjacent. So tan of theta is equal to opposite over adjacent. That equals, well, what was the opposite side? Right, the opposite side was 4.
Tangent is?
Right, and what was the adjacent side?
3. 3.
3.
Great.
The tangent of this angle is 4 over 3. Now let's do another angle on this. Let's call this.
In this case, we have an angle down here and our history and we've got 2 of the sides. So let's label them. This one over here is the hypotenuse, opposite that right angle. This angle splays out towards this line going down here. So this 3 must be the opposite. And I don't need to worry about the adjacent because it doesn't factor.
We have O and H, and West, we must use sine or cos or tan.
ซึ่งเราจะใช้มือซ้ายนะคะงั้นตอนนี้น้องๆทำตามที่ก็คือเอามือซ้ายขึ้นมาเลยค่ะแบบนี้นะคะเสร็จแล้วตกลงกันก่อนนะคะว่านิ้วชี้นี้เราจะแทนด้วยมือ30 องศานิ้วกลางเราจะแทนด้วย45 องศานิ้วนางเราจะแทนด้วย60 องศาแบบนี้นะคะซึ่ง30 องศามันก็คือพายส่วน6นั่นเอง45คือพายส่วน4 60คือพายส่วน3นะคะดังนั้นเนี่ยใช้ได้ทั้ง2แบบเลยนะคะทีนี้ตรงนิ้วค่ะตรงนิ้วเราจะติดลิ้นอยู่นะคะทุกนิ้วติดลิ้นอยู่พอดีนะคะแล้วก็นอกจากบนนิ้วติดลิ้นเนี่ยในมือค่ะในมือนะคะมีส่วน2อยู่จะเขียนตามที่แบบนี้เลยก็ได้นะคะแล้วก็ไซน์เซต้าจะอยู่ทางซ้ายค่ะคอสเซต้าจะอยู่ทางขวานะคะดูง่ายๆค่ะไซน์ก็คือซอโซ่นะไซน์ก็อยู่ทางซ้ายนะคะอีกอันก็เป็นคอสนะคะทางขวาเราจะมาเริ่มหาละสมมติที่จะดูที่มุม30 องศาก่อนก็ให้หักนิ้ว30 องศาลงมานะคะจะดูค่าไซน์30มีค่าเท่าไหร่ก็จะได้เป็นไซน์ทางซ้ายนะคะก็จะได้เป็นรูท1ค่ะ0/2ซึ่งก็มีค่าเท่ากับ1/2นั่นเองนะคะถัดมาอยากรู้ไซน์45บ้างก็หักนิ้วที่เป็นมุม45ลงมาก็คือนิ้วกลางดูเฉพาะทางซ้ายมีอยู่2นิ้วนะคะเพราะฉะนั้นไซน์45จะได้เป็นรูท2
What's the answer of sine of theta, cos of theta, and tan of theta? First, sine equal 3/5. Correct. Cos 4/5. And tan of theta 3/4. Who correct the most? Hands up, hands up. Clap your hand. And F, sine of theta is 3. This is your homework. The last page. Your practice at home, okay? Okay. Thumbs up. Who has questions? No. Okay, see you next time.